Welcome to Chemistry with Caroline. In this video, we're going to look at deuterium labeling in aromatic rings. So a hydrogen atom, right, has one proton and one electron. So its atomic number is 1 and it has the one proton. When there is a hydrogen atom that has also a neutron, so it has a proton and a neutron, its mass is 2, its atomic number is still 1, because the atomic number, of course, is the number of protons that identify that atom and make it the atom that it is. So this weighs twice as much as a proton, and it's used a lot in synthesis studies. So trying to figure out mechanisms. You can label an atom and then track where it goes throughout the course of the reaction. So because it is twice as heavy and it's used so much, it's particularly helpful. And so we often use D, just the letter D, to represent a deuterium. So if we have a labeled reagent, we can sometimes use the chemistry of a molecule to put deuteriums in place of hydrogens. So with a benzene ring, because the pi electrons are attracted to strong acids, we can use a labeled sulfuric acid. So instead of H2SO4, we'd use D2SO4 in labeled water, D2O. And we can replace all of the hydrogens with deuteriums. So it's really just statistics. If you have this large excess of deuteriums in your solution, eventually they'll all exchange and you can replace any proton that was in an acidic environment. So we'll go to the next page and look at the mechanism for how this happens. So I'm going to draw out our benzene ring, and I'm just going to draw one of the hydrogens on so we can see what happens here. And I'm using D+. D+ is coming from my D2SO4, so we're in a strongly acidic environment. We have a large excess of D2SO4. And of course, the pi electrons being negatively charged will be attracted to that proton, that labeled proton. And so I end up with some amount of this molecule that is going to become protonated by a deuterium. And so then, if you have a large excess, when this deprotonation occurs, eventually you'll just be left with deuteriums everywhere, and it'll be the H's that are pulled off because there's just not nearly as many in solution. And so I'm showing you how one can be pulled off, right? And so that would give me now HOD2. So I've got a protonated water, heavy water with D2O that has an H on it. So as long as there's excess, you can just run this for an extended period of time and you can replace all of them. It just has to have an excess of the acid. So that could happen, 5 more times, and that would give you a benzene ring that was completely labeled in deuterium. So we're taking advantage of those pi electrons that are a little more available above and below the plane of the molecule. They're negative nature, so they're going to be attracted to a strong acid like sulfuric acid. So if we label it with deuteriums, we can just do these proton exchanges, and if we have a large excess of it, we can exchange all of the protons for labeled protons for deuteriums. So this has been a look at how we can label an aromatic ring using the properties of the ring and a strong acid that's labeled with deuteriums. If you found this video helpful, please like, subscribe, and share with your friends. Thanks.